Right, next lesson we need to do some questions where we have some binomial distribution sections incorporated within a normal distribution question. So I thought we'd better do a recap on the binomial distribution first. So I don't want this to be too laborious, but quick recap on binomial distribution from last year. So the things that define a binomial distribution: there's a fixed number of trials, n. There's two possible outcomes, success and failure. There's a fixed probability of success, which is labelled p. And the trials are independent of each other. As an example, we can roll a fair die 18 times and let x be the number of sixes. So this then fits all of these. So we've got this fixed number of trials, there's two possible outcomes, you're either going to roll a 6 or you're not. There's a fixed probability of success of a sixth of rolling a 6, and the trials are independent of each other. So if you roll a 6 on one roll, that doesn't affect your probabilities on your next roll. So that's your independence. Expectation, just to remind you, so the expectation in a binomial distribution, so this is like how many sixes I'm expecting to get, is n times p. So if you roll a fair die 18 times, the probability of getting a 6 is a 6, then you're expecting (18 times a 6), so that's my NP, which is equal to 3 sixes. So that's the outcome with the highest probability, and then it'll dip down each side. So unlike the normal distribution, the binomial distribution is only symmetrical if p is equal to a half. It's finite and it's discrete, so x is taking particular values. You're starting at 0. We'll start there at 0. 1, 2, 3, 4, all the way up to 18. And the highest probability here is going to be at 3. So this has a positive skew. You could get all 18 sixes, but it's incredibly unlikely. So the probabilities drop down either side of 3. And then we can find associated probabilities. Parameters for the binomial distribution, sorry, I probably should have put this in earlier. X is binomially distributed, NP. So the two things that define a binomial distribution is the number of trials and the probability of success. So using your calculator, so we can find the probability that x equals 4. This is okay because it's a discrete distribution. And just to remind you from your calculators, I'm sorry this is going to be dark again, but hopefully it's enough. So you go to menu, turn it on first, menu, it's option 7 again. This time we want binomial PD for x equals 4. So it's option 4. It might be good for you to do this at the same time so you can see what's going on. Option 4, and then we just want a variable, we just want one value. X is equal to 4, n is equal to 18, and p is equal to 1 over 6. So 1 divided by 6 equals again, and that comes out as 0.1839. Sorry, say that. 0.1839. Apologies, because I really think you probably I can hardly see my display, so I'm assuming you probably can't. Right, to find the probability that x is less than or equal to 4, we need to go back into this menu. And we need to do binomial CD. So PD gives you a value, and CD is cumulative, so this gives you less than or equal to your particular value, which is fine. We want the probability x is less than or equal to 4. So I need to scroll down, and then option 1 is binomial CD, so that's cumulative distribution. I want a variable again. X is 4, so it's less than or equal to 4, n is 18, p is saved, so it's all saved from the other one, and this is 0.8318 for that one there. I'm sorry, I'm smudging again. And then if you want the probability x is greater than or equal to 3, so x is taking values from 0 all the way up to 18. And if you want the probability that x is greater than or equal to 3, all these probabilities add up to 1. So we can take away the probability that x is less than or equal to 2. So your CD, the cumulative distribution button or function on your calculator, only does less than or equal to probabilities on the binomial. So I need to, instead of using this one, I need to do 1 minus less than or equal to 2. So I am in binomial CD, so I just need to change that 4 to a 2. That gives you 0.4027. And we want to do 1 minus that, so you can store it to x, menu 1, I don't even know if that worked now, store it to x, all clear, menu 1, 1 minus x, so we did this in the normal, didn't we? And you get 0.5973. To there. So do use that store x function on your calculators. I'm looking at that and I've got a rounding error, haven't I? I think that should be a 7 there. I'll let you look at that. And then the other thing to remember is, because it's discrete, the probability that x is less than 5 is the same as less than or equal to 4, because we're just taking integer values. And the probability x is greater than or equal to 3 is the same as the probability x is bigger than 2. So x is taking integer values between 0 and 18. I'm hoping that's enough of a recap. I've just chucked a few questions on your lesson notes because you need this for next lesson. So hopefully you can just flat through those and it won't cause any problems. But if you've got any missing little bits on that, then do let me know and I'll go over it with you. The other one to think about as well is the probability that x is greater than or equal to 1, so at least 1, which is all of that lot. That's 1 minus the probability x equals 0. So don't forget your zeros, and this one comes up quite a lot in questions. I think that's it.